Have you ever wondered if you could join two metals together without spending a dime? Watch this video to the end and learn it. Get a 220 volts to 12 volt step-down transformer, two 1 in 5408 rectifier diodes, several large electrolytic capacitors connected in parallel, a fuse, two welding electrodes. How it works: 1. The transformer lowers the voltage. The transformer converts 220 volts AC mains to about 12 volts AC. This provides a safer low voltage while allowing high current capability. 2. The diodes rectify the AC. The 1 in 5408 diodes convert the transformer's AC output into pulsating DC. The capacitors need DC to charge properly. 3. The capacitors store energy. The capacitors charge up to approximately the peak voltage of the rectified 12V supply. The energy stored in the capacitor bank is E equals frac 1 to CVA, where equals stored energy equals total capacitance equals capacitor voltage. When several capacitors are connected in parallel, their capacitances add together, allowing more energy storage. 4. The electrodes touch the metal. The two welding probes are placed on a thin metal strip, such as nickel strip used for battery packs. 5. Energy is discharged rapidly. When the electrodes are connected through the workpiece, the capacitor bank discharges almost instantly because the voltage is low but the current is extremely high for a very short time. The metal at the contact point heats up rapidly. 6. The metal welds. The intense localized heat melts the contact point between the two metal pieces, creating a spot weld after cooling. Important limitation: a 12V 6A transformer with only a few electrolytic capacitors usually produces a very weak spot welder. It may weld thin nickel strips, but it is far less powerful than microwave transformer most spot welders, capacitor discharge welders using supercapacitors, battery-powered high-current spot welders. Thanks for watching.